Another thing you're likely to come across when you're reading old code is the void pointer. You'll see it in function parameters especially. Oh, this function takes a void pointer. When a function returns void, that means it doesn't return anything. So you might be tempted to think that void pointer means a pointer to nothing, but what it actually means is a pointer to anything. A little bit like, say, an object reference in a world where everything inherits from object. In C++, there isn't anything that everybody inherits from. And so void pointers are used like that. You can take any kind of pointer and cast it to a void pointer successfully. And you can take a void pointer and cast it back to any kind of pointer you like without a runtime error. Of course, if it doesn't really point to whatever you've just casted it to, really bad things happen. So you'll see a function that takes a void pointer, and the first thing the pointer does is turn around and cast that to an employee star, whatever it thinks it points to, and then go ahead and start using member functions of employee, let's say, based on the fact that you've cast it to that. This is an extraordinarily dangerous behavior. There really isn't any runtime checking going on. If for some reason somebody passes an insurance policy pointer to this function, it's going to try to cast it to an employee pointer, then it's going to try to go ahead and use it as that. It's going to interpret the memory as though it was an employee object. And if it isn't an employee object, really bad things happen. So a much more type-safe approach would be, don't take a void pointer. If this function takes, any kind of bank account, then have it take a bank account pointer, a base class. And then you can use either polymorphism to invoke the right subclass method depending on what subclass thing the pointer actually points to. Or you could use the static and dynamic cast that we've covered elsewhere to get it into being a savings account pointer so that you can call some method. The problem with void pointer is it just takes type safety, which is one of the best parts of C++, and throws it away and says, who cares? It's all just ones and zeros. I'll figure out what it is. And that's what we like to sometimes call enough rope to blow your foot off, to mix metaphors. C++ gives you a lot of control, and things like void pointer are a way to say, I'm the one running the show here, I'll do whatever I like. It can be a powerful technique, but it's such a dangerous technique that you really shouldn't be using it. I'll show you just how compliant things are and how little they complain while you do bad things. I'm calling here a function called useSomething, and I'm passing into it a series of different pointers. This one is the address of I1, an integer that currently holds the value 7. This one is the address of the member of the struct point, the x member. So if we just scroll up a little so you can see those values, right? P.x was set to 2. So I'm going to take the address of that piece of a struct. Then I'm going to take the address of the whole struct and pass that into useSomething. And then I'm going to take the function pointer, because when you just say the name of a function without the open and close brackets, that's a function pointer, and I'm going to pass that into useSomething. useSomething is obviously a very accommodating and happy-go-lucky kind of a function. Sure enough, it takes a void pointer. And what it does is, it's positive it's getting an integer. So it just takes that something and casts it to being an integer pointer, and then uses it. Now I'm going to do a fairly mild use. I'm just going to print it out onto the screen. There are a lot worse things I could do. So let's go in here and step over each of these in turn. So this is printed out 7, which is great. That I1 is 7. I printed out 7. This void star is looking like a pretty cool thing. And if I step over again here, remember P.x has a value of 2. So sure enough, there's 2 on the screen. So that's fine. They were both integers. Now what about when I pass in this whole point? You notice no errors, no exceptions, no badness, and it actually even prints out 2 on the screen. That's because it goes to the memory where the point starts and says, I know what you are, you're an integer, and then interprets the bits that it finds there as an integer. And the bits that it finds there are the first element of the struct, and they do happen to map out back out to the value of 2. But if anyone ever changed the layout of the struct so that something different was first, this would stop working. This is exactly the sort of thing that breaks code that uses void pointers. Now, what about when I pass in this function pointer? If I hover over it, you can see that it has a numerical value. The debugger, however, is aware that it's a function. It even uses the little function symbol here. So I step over, no errors, no complaints, and a number prints out on the screen, which is the numerical address of that pointer. Super non-useful. If you're absolutely positively sure that you'll always be passed an integer, you can get away with void pointers, and that's why you'll see them in other people's code. But you see that if anybody uses it in an unexpected way, you just have no protection. I will point out that you do have to cast it. You can't ask the object to know what it is. So I'm just going to uncomment these lines and build. See, right away I have red wigglies. The motivation behind these lines is like, oh, something, you know what you are, so I'll just give you to see out and we'll be fine. And that's like a polymorphic way of thinking, which would be great if we weren't using void pointers. But we are using void pointers, and the compiler needs to figure out which of the many overloads in IOStream of this operator to use here. Is it the one that takes the output stream on one side and an integer on the other, or the output stream and a string, or the output stream and any other many number of kinds of types? And it doesn't know the type, and so it can't do that. Now here, when I've cast it over to an integer, it knows the type of this, it knows it's an integer, and it can do it. So you can't get any kind of runtime goodness. You have to say, I believe that this is an integer pointer or an employee pointer, and I'm going to do the cast. That's the danger of a void pointer. You have to be sure that you know what it's really pointing to.